Okay, I'm going to get into some nitty-gritty details of boxing. If you've had enough boxing, feel free to skip this video. But I think it's important to be intelligent and understand what your language is doing. So let's do another example. Object O gets 5. What is going to happen when I do this? Can you diagram it for me instead of having me do it? Probably not, because this is a recording or a video and you're watching it. So allow me to diagram it as we have. We have on the left here our stack, and on the right here is our heap. And we said, oh, yes, well, O is a reference. It's stored on the stack because it's in a local method here. So here's O, right? And O references this, or points to, or stores the address of this boxed object with some meta information I'll talk about in other videos. Don't worry about that for now. And the boxed value, which is 5. Okay, so there we go. That's hopefully nothing new there. Now let's unbox this thing. Well, I can unbox it like so. This causes the compiler to unbox the value. Now we're getting a red squiggly I'll talk about in a second. But the int O says, hey, I know this is an int. Please unbox it. All right. Well, that would cause the compiler to have to store this value on the stack here. So here you go. Here's the value. Now notice there's no name for this value. This value is just temporarily sitting there waiting to be consumed. But we're not consuming it. All right? In no way are we saying, hey, I need to store that value somewhere. We're just saying, hey, go unbox it. And the compiler thinks, you know, I may be a compiler, but I'm pretty smart, and you're wasting my time. I'm just going to have to emit instructions that put this value on the stack, and then I'm going to have to erase it off, or we call it popping it off. And that's a waste of my time. So look here. It says, hey, only assignment, call, increment, decrement, and new object expressions can be used as a statement. Now, I really should do a video on the differences between what expressions are versus statements. And I should also do a video on why assignment, call, increment, decrement, and new object expressions are special and can be statements. That's definitely, maybe I'll make a note for that. Hold on, let me write down a note. Okay, but the compiler is just saying, hey, you're wasting my time. I'm not going to allow that to happen. So one way to consume the value I just showed you, we could do that. All right, and so in that case, what would happen is we have I is on the stack, and then sure enough, we do an unbox like so. So that forces the unbox, this temporary value memory stored to store the value of the unboxed instance. Okay, and then what will happen is the compiler underneath in all the dirty low-level assembly code you probably don't want to learn about, but if you want to, go watch my assembly programming playlist. But anyway, it will copy this unboxed value into I. So now that we're consuming it, and then it'll just pop it off. So the compiler's like, oh, you're no longer wasting my time. That's fine. I'll do the assignment. Well, what's another way we could consume the unboxed value? Well, even though integers are primitive and they're basically as basic as it gets, the CLR kind of gives us the best of both worlds, because they're primitive in one form, and then if I want to treat them like an object in other forms, that will. So I can say .toString here, which is lame, because I could just say O.toString, and it would figure that out. Now, toString, if I don't console write line the result, it's kind of useless, but it doesn't matter. It's still a method. And as far as the compiler is concerned, it has no idea what toString means. It just says, oh, you're calling a method on an instance? That's fine. Whatever. Go ahead. So when I say O.toString, that is going to call toString on this boxed instance out here. All right, now notice I've gotten rid of I. So let me erase I off my stack. But again, I'm unboxing this value. So boom, here's the temporary unboxed, copied from heap memory unboxed value, and we call toString on it. So then, in this case, toString is going to run on this temporary value sitting on the stack. Now, when toString returns, the compiler is smart enough to say, hey, we're not going to use that anymore. Let's vaporize it. So there's a difference between unboxing versus actually consuming the value. Now, I think this example is probably interesting enough to examine the actual missile. So let me bring up the command prompt here. If you remember, I have the C macro, which will compile my main class and disassemble it using the reflector, which you can find online if you Google .NET reflector. But then it will allow us to look at the intermediate code. And in this playlist, I haven't really explained this, so allow me to do so here. I know I explained this in other videos, but I don't know where you came into my playlist, so it wouldn't hurt to explain it again. When you write C#, we run a command on that. When you hit Control-Shift-B, it runs the C# compiler, which generates Microsoft Intermediate Language. Okay, and then your executable is in this Microsoft Intermediate Language form. You run this executable, or you execute it. That sounds kind of bloody, doesn't it? And at runtime, the jitter kicks in, the just-in-time compiler. And the reason we call it just-in-time is it compiles the methods as you need them. So you call a method and it says, oh, let me compile that. And further compilation happens down to the native assembly or machine language. All right, machine language instructions. This is what your black chip inside of your CPU can actually execute. It's literally ones and zeros. Ooh, sounds so technical. Anyway, that's the jitter's job. Well, when I compile this, like I said, it gives me this missile, right? And then all these stack and heap things I've been drawing, the stack and heap, I've been explaining them at the machine, how the machine actually would execute and use the data. But the missile has a stack and heap, okay, very much like this stack and heap, but it operates just slightly differently. And then there's this thing called the locals array, blah blah blah. I don't want to get into all the details for now. Just for now, know that when I reflect my code, we're looking at this intermediate language, right? And the number one question you're probably asking yourself is why this intermediate step? Why don't you just go directly to machine code? Well, you can. Go look up ngen, ngen.exe, but that's another discussion for another time. There's actually advantages to this because I can have VB write to this, and I can have other languages. In my schooling, I actually wrote a language. I can't remember what we called it, but I wrote my compiler, and it compiled the missile. And anyway, you can have all these machines. Well, I'm getting off track. We're going to look at some missile here when I do my reflector. So let me bring the command prompt up. C. Here's the reflector. I'm open up main class. This is the executable that I compiled. And here's main class. If I look at main, and I say, hey, show me the C#. Okay, this should look pretty familiar. Doesn't this look like the, let me get rid of this over here. This should look like the code we have over here, huh? Well, now I want to say, hey, show me the missile, or IL is what they call it, intermediate language, but the MS is for Microsoft. Show me that intermediate language. Voila. Okay? Now, don't let this scare you. It looks really scary, doesn't it? But it's actually hopefully straightforward. And I can actually explain how it's working over here. So, no op means do nothing. The compiler will insert these so the debugger can stop at certain points in your code. Load constant I4 value 5 on the stack. 4-byte integer. Give me a 5. Throw it on the stack. Look at this. Box it. Okay, box it to the heap. Alright, store that reference away in O. That's what the O is. Load local. Don't stress that. Unbox. Alright, aren't we doing an unbox here? Now, this is kind of interesting. This code doesn't match this code over here. Why? Because I didn't save the file when I did the compilation. Excuse me, let me save that file and then rerun the compiler and the reflector. Okay, getting back. Oh, that's so embarrassing. Getting back to this. So we box it, and then look, I'm calling toString on it, and then don't worry about these. But then, oh, look, here's an unbox. Alright, and that unbox is operating right here. And then we say, hey, call toString on that thing. So I'm not going to get into all the details of the instructions here, but basically you can see the box and unbox. That's a missile level kind of thing. Anyway.